Hi everyone, I am Muhammad Najwan and this is my software engineering modeling presentation. In this video, I'll be analyzing the popular multiplayer game Among Us by breaking it down using different software diagrams. You'll see how user behavior, system logic, and gameplay mechanics can be modeled and understood through UML and flow. I chose Among Us because it's a perfect example of a real-time multiplayer interactive game with clear roles, events, and game state. It's fun and chaotic on the surface, but underneath, it's built on very structured logic, making it ideal for software modeling. Here's a quick overview of key features in the app and how I mapped them to modeling diagrams. Each of these diagrams will help explain the game from a developer's point of view. Let's begin with the use case diagram. This shows what the player can do in the game, such as joining a match, reporting a body, calling an emergency meeting, or completing tasks. Imposters have unique use cases like sabotaging and eliminating players. The game server is responsible for handling all logic like voting and tracking player state. This diagram helps us understand the user system relationship at a high level. Activity diagram, which focuses on the crewmate's task flow. The player spawns on the map, moves around, and completes tasks. If they fail a task, they retry. If a dead body is found, flow switches to a voting round. Once tasks are complete, the crew wins. This diagram helps model decision points and repeated gameplay actions. The sequence diagram focuses on the emergency meeting event. A player reports a body, the server notifies all players, they submit votes, and the server tallies the results. Whether someone is ejected or not, the game resumes afterward. This sequence shows how communication and real time updates are structured behind the scenes. Here's the state diagram, which shows how a player's status changes throughout the game. They start alive, but can either be killed or voted out, becoming a ghost. Ghosts can still perform tasks but can't participate in discussions. The game ends when either imposters win or crewmates finish all tasks. This is great for modeling life cycle transitions within a match. Finally, we have the class diagram, which shows the internal system architecture. Main classes include player, task, game, and server. Players can move, vote, and complete tasks. The game manages the session while the server handles logic. This object oriented structure helps developers understand how the system's components interact. In conclusion, modeling Among Us through software diagrams helped me break down its logic, roles, and structure. Each diagram, from use case to class, gave me a new perspective on how a multiplayer system works and how game design can be planned using modeling techniques. Thanks so much for watching. This was my software engineering modeling presentation for Among Us. If you enjoyed it or found it helpful, feel free to like or comment. And remember, trust no one. See you next round.